Alright, so this lesson is about factoring again, and this time we're going to be factoring by grouping. And so when do we use it? We're going to use factor by grouping when there are 4 terms. So in this particular example, you can see that I've got 1, 2, 3, 4 terms. So this is an appropriate problem to use factor by grouping. Sorry, let me get that clear. Okay. Now, it's important for you to understand that yesterday's, or not yesterday's, but the lesson before this about greatest common factor, it still applies. So when I did those notes, I said that you always have to do greatest common factor first. So before starting with grouping, I'm going to try and look for a common factor. And in this particular example, these are actually all divisible by 5. So I am going to pull out 5 as a greatest common factor. Now, when I do that, I'm left with a 4xy plus 10x plus 6y, and then 5 goes into 75, should be 15 times. Alright, now this 5 is just going to hang out in the front, okay? Don't lose it. It's a part of your answer. You have to multiply 5 by whatever you get, but essentially we're not going to work with that right now. We're only going to now work with these 4 terms. Now, grouping is done exactly like the word means, so we're going to go ahead and group these in sets of 2. Okay, and when I group them in a set of 2, I am then going to look for a common factor between those 2 things. So remember I said this 5 is just kind of going to hang out. Sometimes I draw an arrow and I just write it down on the answer line. You can write it again off to the side and just have a big bracket. So let's see what we get. Alright, so just looking at these 2, what do they have in common? They're divisible by 2, and they both have x. So 2x, and then when I'm going to have 2y plus 5. Okay? So that's just these 2 together, is this. Now over here, what do these 2 have in common? Well, they're both going to be divisible by 3. So when I divide by 3, I'm going to get 2y plus 5. Look what just happened. These are exactly the same. So what does that mean? That means that 2y plus 5 is your new common factor. Because it's a part of both of them, you can actually essentially just pull it off, and it's a factor, divide by it on each one. So remember I told you we're not going to lose this 5. It's just kind of coming down. This 2y plus 5, we're going to write it 1 time. And I'm basically taking this and dividing by 2y plus 5, which means I have left 2x. And then here, divide by 2y plus 5, and I'm going to have just plus 3. So this is my final answer. 5 times 2y plus 5 times 2x plus 3. If I were to multiply this all the way back out, combine my like terms, I would get the original. Alright, so that was a little bit complicated because we had the extra common factor. Let's go ahead and try some others. So example number 2 is a bit more straightforward. I've got x to the third minus 2x squared plus x minus 2. So again, look for a common factor. Nope, nothing in common on all of them. So there's no common factor. So I'm going to group them into sets of 2. Now what do these 2 have in common? Well, they both have at least x squared. So when I divide by x squared, x to the third, take away the x squared, you're going to be left with x to the first power. Minus 2x squared, divide by x squared, leaves me minus 2. Okay? Now, what do these 2 have in common? So at your house, you're sitting there and you're either thinking nothing, or you might be thinking 1, okay? And basically what I'm going to tell you is I'm going to tell you that if they don't have anything else in common, you need to pull out the common factor 1. Everything is divisible by 1, so I can just say that I'm going to have plus 1, and I'm dividing by 1, so whenever you divide by 1, you know that it doesn't change. So this is what it looks like. Okay, take a minute and process that. All right, from there, the x minus 2, that's now your common factor, so you're going to have x minus 2. And when I divide this one by x minus 2, I'm left with x squared. When I divide this one by x minus 2, I'm left with plus 1. And that's why we needed that plus 1, because if I don't put that 1 and I try multiplying it back out, it won't be correct, okay? So anytime they don't have something else in common, you need to use positive 1. All right, number 3 example. 15uv minus 35u minus 6v plus 14. Okay? First of all, do they all have anything in common? Greatest common factor? No. So these two together, they can both be divided by 5, and they also both have a u. So if I do that, I'm going to be left with 3v minus 7. Now these two, okay, what do they have in common? It's just going to be 2. But I'm going to draw your attention to this negative. This is a big deal. If you have a negative in front, okay, remember the last lesson. If you have a negative in front, you must pull out the negative. So I'm going to pull out a negative 2. So negative 6 divided by negative 2, that's going to be positive 3v. 14 divided by negative 2, that's negative 7. Be careful with your signs. So they both have 3v minus 7, and then 5u minus 2. Now, you might be wondering, okay, are they always the same? And the answer is yes. And if they're not the same, it means you've probably made a mistake. Okay? All right, so example number 4, we've got 20 x to the third plus 16x squared plus 15x plus 12. If you haven't tried any on your own, this is a perfect opportunity for you to pause the video. Try this one on your own. First things first, do they all have anything in common? And again, the answer looks like no. So we're going to do them 2 at a time, grouping. So for this, we can pull out a common factor of 4, and we also, both of them have at least x squared. So I'm left with 5x plus 4. These two are both divisible by 3. So I've got 5x plus 4. So my answer is 5x plus 4 and 4x squared plus 3. Now, one of the things I sometimes see students do is they know that this parenthesis should match this one. So instead of actually dividing, they just write the same thing twice. Well, you need to be careful, because if you have any sign issues, doing the math here and doing the math here will help you make sure that you get them right. Okay, so for example, sometimes, a student will get plus here and minus here, and really they've made a mistake here. But if you do this one, you can double check your math for both. If you don't bother doing this one, you would never even know you made a mistake. Okay, so even though they should match, you need to do the math where you actually take 15 divided by 3 and 12 divided by 3. Okay?